The goal of this video is to explain you data warehouse, data lake, and data lakehouse in a language that even a child can understand it easily. To begin with, we'll cover some essential concepts such as OLTP, OLAP, ETL, and then we'll move to the main topic. We all use Blinkit. If you are in India, you know that it's a fast e-commerce service which can deliver things in let's say 30 minutes, short time duration. Now, when you place an order on your Blinkit app, internally the order will get recorded into some database. So let's say you're using Postgre database for orders. Now, if you look at any organization, they don't use one type of database. Usually they have multiple databases and data sources. So let's say for your inventory, you might have a different database in MongoDB where you are storing the inventory of items from various stores, okay? So this is called structured data because it is in a tabular format. You might also have unstructured data, such as you might be using the chatbot to talk to Blinkit, and all these chat transcripts are stored as unstructured data. You might have streaming data where you're locating, where your driver is, and all that data is stored as a streaming data in some backend server. So if you think about Blinkit or any other business, pretty much, they will have multiple data sources, which will include unstructured databases and structured databases. Now, in terms of unstructured data, you can have all these, let's say, chat transcripts, right? So you have chat transcript. Let's say this chat transcript is stored as a JSON object in your Amazon S3 bucket. You might also have some clickstream data, right? Let's say if you are using any app, let's say Netflix, etc., they track where you are clicking and in which area you are spending more time, to get metrics on the usability of your app. You might also have log files, application logs, programming logs, and all these data is pretty useful. So you have unstructured data and structured data. And now, as a business executive, you will have a lot of questions. Let's say you are a CEO of Blinkit or you are a business manager in Blinkit. You will have questions such as, what are the percentage of orders that were delivered in full and on time? And you might ask this question across time axis, let's say in last month or in last 6 months. What is that percentage of orders that were delivered in full and on time? You might have different question, which stores are receiving the low ratings, because you might want to investigate. You want to fix the issues. Diwali is coming, or let's say Christmas is coming, and we want to offer some discounts. So how do we do that to increase customer satisfaction and boost the revenue? Now, if you have worked in SQL, you will be like, oh, this first question is easy actually. Say you have two databases like orders and inventory. You can perform maybe some SQL join and you can get the answer, right, between these two tables. And that is valid. So essentially, you take all your tables, then you have to perform some kind of aggregation, right? In order to get an answer, okay, which orders were delivered in full. So if you look at this particular order, this customer ID and this order ID, he placed these two items, right? And they were delivered at a different time. And then this is the product ID and this is store ID, okay? So now you can perform aggregation and you can say that among these two orders, order quantity was 2 and delivered quantity was also 2. So when you are ordering two things and you get two things, it is called order delivered in full. Sometimes you order two things, but you get only one thing. So that's a partial delivery. But here it's order delivered in full. So now you can perform normalization and you can say, yeah, order delivered in full. Yes, because you ordered 2 and the item that were delivered is also 2. Order was delivered in time? Yes. Let's say you were promised 30-minute delivery or one-day delivery if you are Amazon Prime. It was delivered on time as per expectation, so you can say yes. So you can directly get your answer by just performing the SQL between two tables on fly. But if you store this value in an aggregation table, then another normalization table, your analytics become easier. So the data that you see here is called analytics ready data. Okay, this data is called analytics ready. Whereas this data is transactional data. Whatever is coming through your app, you're storing in your database. But to perform analytics, you need a different shape and form of data. So we are performing all those transformation here. So then this data gets usually stored in data warehouse. Okay. So this database is different, and this data warehouse is mainly used for analytics ready data. Now, the steps that we perform there, the first step is called extract. So in order to perform analytics, or in order to prepare analytics ready data, you performed extraction process from your transactional databases. Then you performed transformation. Okay, so extraction, then transformation, right? Aggregation, normalization, cleaning bad values, currency conversion, changing units, all these are transformation. And then you performed something called load, which is you loaded data into your data warehouse. So to summarize, you had all these data sources. Then you perform something called ETL, extract, transform, load, to make the data analytics ready and loaded that into a data warehouse so that you can plug your Power BI dashboard to your data warehouse, or you can get data in Excel and build a report in Excel. Doesn't matter which tool you are using, right? You can use Power BI, you can use Tableau, you can use Excel, doesn't matter. But once the data is ready, analytics ready in data warehouse, your analytics becomes much more easier. Folks, you can do directly analytics on these two, but it will be very painful. Okay, so that is the whole purpose of doing this transformation. Now with that, you can get answers on your questions such as percentage of order delivered or which stores are receiving low ratings. But look at the third question. Festival season is coming. What kind of discount can increase the value? Now see, these first two questions are kind of related to descriptive analytics, whereas the third question is like predicting future. You are becoming like an astrologer. You want to know, okay, if I offer discount in this particular store, then my customers will be more happier, or I will get a revenue boost. So this is predictive analytics, folks. And you know that for predictive analytics, you need to use AI. So data warehouse data is consumed by two teams, your analytics team and AI team. AI team also use this data to build the models and perform some predictive analytics. So the first portion here is called OLTP, online transaction processing, because this is mission critical data. All your transactions are getting stored in this data, right? And the second portion is called OLAP, online analytical processing. Okay, so OLTP is online transaction processing. See, online transaction processing and online analytical processing. Now you might ask question, okay, why don't you do your analytics directly on OLTP? Well, OLTP is a mission critical database. If some data analyst is running a heavy query for analytics, okay, let's say this is data analyst, and he's slowing down your database, and now your customers are placing order on your app, this database will be affected, right? They might cause an outage. So you don't want to touch your mission critical data where your transactions are involved. Analytics is like kind of secondary, so it can wait. So therefore it is recommended you create a copy. One very obvious option you have is just you create a replica of this two database, and your data analyst directly performs query on this. This will also work. But anyway, since you are performing a replica, why don't you do some transformation and make the job of your data analyst or your AI engineer easier? That is the entire purpose of doing this ETL data warehouse and making data analytics ready. We have previously seen that you can have all kind of data sources, your databases, streaming logs, PDF files, images. All of those can be transformed using ETL process. You store them into data warehouse and then you perform your analytics or ML. Now, when I was at Bloomberg and even in other companies where I have worked with, what used to happen is, let's say if you have log data, see, this will be on application server. And at Bloomberg, we used to store logs for only last 7 days. See, these are not database servers. These are the application servers where your application backend is running. So they don't have that data infrastructure. So log files, images, etc. You can store them in a limited quantity. And same thing with all this data, right? All these OLTP databases, they don't store transactions of, let's say last 20 years, 30 years. They have some limitation. There is some purging logic that is going on. And when you talk about data warehouse, it is also costly because data warehouses are usually on cloud and there is a compute and storage cost. So you can't store infinite amount of information in data warehouse. Also, this stores mainly structured data. So what people do is they extract all this OLTP data into a staging area. Staging area is another database basically. And you can imagine as some, let's say directory on cloud. Let's say you have OneDrive. Just imagine there is some directory and you're dumping all the data. Okay, it's like you're dumping all your data, all your historical data. And this is usually a cheap cloud storage. So you don't have to worry about your cost, etc. You can store last 20, 50 years data. You can also store time revision history, all of that. It is sort of like you have a showroom of shoes and the staging area is, you have this room behind the scenes where things are kind of randomly placed, all these boxes. But when it moves to data warehouse, you want to put things in a nice structured way so that it is BI ready. Essentially, when your customers are coming, it is kind of organized. Okay. So that is what the staging area is. And after you transform and load, see this extract part moved here, by the way. Then comes staging area. Then you do transformation and load. And when data comes here it is BI ready. Your analytics ready data is present. So this staging area is nothing but a data lake. Okay. Data lake is a simple concept, folks. It's some cloud location where you are dumping all your data. And the benefit is that, let's say you are doing some analytics, AI, and you want to go back to your source data, then you can go here. Your data lake will have all your source raw data, right? So this is like a raw, messy, dirty data. You'll be like, oh, but can't I go here? No, like these are again application servers. Here you will be deleting some of these data. It won't have all the history. Also, if you're doing some time tracking, right, when the record got updated, that kind of thing won't be available. Whereas in data lake, it's like a dump yard. You have all the data. So if you want to know what happened before that transformation occurred, if you want to do some audit, let's say there is some regulatory requirement and you want to do some audit. So in that case, having this data lake is useful. There are many solutions. Amazon S3, you might know about S3 object store, right? So usually in the object store, you can store your JSON file, your Parquet file, whatever. It's just objects. It doesn't have the features of a relational database, but it provides a very cheap storage. Similarly, you might have heard about ADLS, Azure Data Lake Storage. That is another data lake, Google Cloud Storage. There are other solutions as well. But let's summarize the difference between data lake and data warehouse. Data lake stores raw data. Data warehouse stores clean, structured, analytics ready data. It's like you went to a store, bought a bunch of vegetables, which has, which are a little bit dirty and all of that, and you're putting it in some container. That is your data lake. Then you clean them, you cut them, you put them into a fridge. That is your data warehouse. The data type in data lake is both structured and unstructured. It can store both. Whereas in data warehouse, mostly structured data so that you can run SQL query, you can do BI on top of it. And the storage cost is cheap in S3 and ADLS, whereas data warehouse such as Amazon Redshift, Google BigQuery, they are costlier. Here in data lake, if you want to do query on your raw data, let's say you have S3, you have a bunch of JSON objects, right? So you can use this tool called Athena to perform queries, but it will be slower. Whereas data warehouses are like proper databases. So if you are running SQL queries, they are optimized for performance, and there is a guarantee of ACID transaction. A means atomicity, right? Then C means consistency and so on. We'll go over this definition later. But what atomicity means is, let's say you are inserting a record in a database and the record has invoice. Okay, so that is one record. And let's say invoice has 3 orders, right? So let's say you are inserting 3 records in your order table. If your transaction is following this rule of atomicity, it will only insert 4 records. Let's say if it fails in inserting one of the records, then it will not insert remaining 3 records. It's like there is a consistency into this transaction. So that is offered by data warehouse, but data lake doesn't offer it. All right. So I hope you understood the difference between data lake and data warehouse. Now you might ask, what exactly is data lakehouse? Folks, simple. It combines the features of both the worlds, data lake and data warehouse, into a unified platform. And there are 2 examples. Delta Lake, which is a solution by Databricks, and then Iceberg, which is by Apache. These 2 are the examples of popular data lakes. I hope that gave you some clarity on this topic. If you have any questions, there is a comment box below. Thank you for watching.